Let's take a look at some sample problems on section 8.4. And before we begin that, I just want to read you a statement that's found on page 392 in the textbook. And this is an agreement on the domain. The domain of a relation is assumed to be all real numbers that produce real numbers when substituted for the independent variable. In general, the domain of a function defined by an algebraic expression is all real numbers except those numbers that lead to division by zero or an even root of a negative number. So that's on page 392. If you want to revisit that before you work on the homework, that probably would be a good idea. So on page 397, we'll start with number 8. And for exercises 3 through 14, for each relation, decide whether it is a function and give the domain and the range. So as we look at number 8, it's a little bit different. I've done these before. So I've done most of these examples in the lecture. So in number 8, we kind of have an illustration of what's going on. 9 is mapped to number 32. 11 is mapped to 47. 4 is mapped to 47. 17 to negative 69. And 15 to 14. So as we can see, each x is matched to 1 and only one y. So that means we do have a function. And our domain, I'm just going to use a D to represent domain. We consist of 4, 9, 11, 17, and 25. 4, 9, 11, 17, and 25. While our range would consist of negative 69, 14, 32, and 47. Okay, now let's move on to number 16. It says decide whether the given relation defines y as a function of x. Give the domain. Okay, it turns out when we're working with equations, the problem ones that won't be function is if we have even powers of y, or if we have a linear, we have less than, greater than, less than or equal to, greater than, or typically that's a shaded area, so those would not be functions. So even powers of y and inequalities would be not functions. They would be relations but not functions. Okay. So odd powers like in 16 are okay. So y equals x cubed is a function. And in terms of the domain, we're looking for anything that would create a 0 in the denominator or a negative inside a radical. So domain restrictions have to be made if 0, we can have no 0 in denominator, no negative inside a radical, inside a square root. Okay, so in this case we have no restrictions, so the domain would be all real numbers. And let's see, they may be doing this in interval notation. I don't care which one you would give me, either one's correct. X equals y to the fourth is an even power of y, so it's not a function. Looks like our domain, we would have Will we have any restrictions on, they certainly couldn't be negative if we're talking about y to the fourth. So if we did it in interval notation, it would look like that. Okay, next one, x minus y is less than 3. Not a function. And again, all reals, no restrictions there. Or minus infinity to infinity. 22, we have y equals the negative square root of x, would be a function. And x would have to be greater than or equal to 0, or 0 to infinity. Since it's inside the radical, we would have to have it be non-negative. 24, negative 3 over x, would be a function. And this would be the set of all x such that x is not equal to 0. So we'd go from minus infinity to 0, and then from 0 to positive infinity, if we're doing it with interval notation. Okay, that would be a function. Now we need 9 minus 2x to be greater than 0, negative 2x to be greater than negative 9. Divide by negative 2 switches that to, so it's the set of all x such that x is less than 9/2. So we go from minus infinity to 9/2 in interval notation. Okay, 28, y equals negative 7 over x minus 7. That would be a function. Set of all x such that x is not equal to 7. We can't have a 0 denominator. So for interval notation, we go from minus infinity to 7, not including 7, and from 7 to plus infinity. Okay, number 30. The graph shows the megawatts of electricity used on a record-breaking summer day in Sacramento, California. And here's kind of what the graph looks like. Okay, so part A. Is the graph a graph of a function? Yes, it is a function. B. What's the domain? Well, the x value goes from 0 to 24, inclusive. Alright. C. Estimate the number of megawatts of electricity at 8 a.m. Okay, it looks to be 8 a.m. between 11 and 13, so let's say about 1200. At what time was the most electricity used and the least? The most was, looks like about 18. So that would be 6 p.m. It's 6 hours after 12 noon, so 6 p.m. And the least used was at, it looks like about 4 a.m. And then finally E. Alright, when was it at 1300? That looks like about slightly after 8, so maybe about 9 <laughs> 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 Okay, turning the page. We're supposed to sketch these. Okay, and what I'm going to base my sketch on is knowing that these are linear functions. And graph paper would be better. But anyway, our y-intercept is -1. Our slope is 4, so we're going to go up 4, 2, 4, and over 1. And there's our function. Okay, in 52, we have g of x, or y, is equal to -4. Two, three, 4. 1, 2, 3. Okay. So that would be a horizontal line. Okay, in number 54, an equation that defines y as a function of x is given. Solve for y in terms of x and replace y with functional notation f of x. Then find f of 3. So in 54 we have y minus 3x squared equals 2. So we want to add 3x squared to both sides to get the y by itself. Alright, so that would be f of x equals 3x squared plus 2. So f of 3 would be 3 times 3 squared is 9. So 27 plus 2 is 29. Alright, 64. In 1787, Jacques Charles noticed that gases expand when heated and contract when cooled. Suppose that a particular gas follows the model f of x equals 5/3 x plus 455, where x is the temperature in Celsius and f of x is the volume in cubic centimeters.